Thank you. Good morning again. In this and all other ASHRAE meetings, we will act with honesty, fairness, courtesy, competence, inclusiveness, and respect for others, in which exemplify our core values of excellence, commitment, integrity, collaboration, volunteerism, and diversity, and we shall avoid all real or perceived conflicts of interest. Good morning once again, and we are sorry for the late start, but Trinidad has been experiencing some unfortunate weather, and it's going to come across the region as well. So we had a little bit of a technical issue getting on this morning. Just a few house rules. Please keep your mic muted during the process of this session. If you have any questions, please type them in the chat box. If not, we'll have an open question and answer segment, and we should type any questions there. They would be answered by the moderators. It's an open discussion. We'd like that everyone keep their comments, even though it's a very passionate discussion that we're going to have this morning. We want to respect everyone's opinions, and we want to ensure that everyone's voices are heard. We know that it is going to be a very, very, very educational discussion. And again, we want to share as much information as possible. I'd like to pass over to the moderators for the session, Mr. Desi Lara and Renel. I'm not seeing Renel. So let me add them in.
Hi, good morning, everyone. I'm so happy to welcome you all to this session this morning. Our session on energy use and climate resilience in Trinidad and Tobago. Firstly, I'd like to thank you, the audience, for joining us. We're really happy that you're here on a very rainy and in some places stormy morning. And I'd also like to thank our star-studded panelists who are from the energy sector and who will be speaking to us this morning. Our goal really is to educate, to innovate. And by that, we mean that we really just want to continue the discussions that are happening within the energy sector in Trinidad and Tobago, things around the country's energy transition. We want to spark new ideas and new conversations. So I really encourage you all to ask questions, which you can do, as Kieran said, by placing them in the chat, to learn from our speakers and also to learn from each other. So Desi, over to you.
Thank you again, Renel. Well, I'll start off. Who are the Trinidad and Tobago Island Innovation Ambassadors? We are the Trinidad and Tobago contingent of Island Innovation. Island Innovation is a social enterprise engaged in building a global network geared towards connecting islands around the world and fostering positive change through the sustainable development of island states. Our virtual Island Summit 2021 is being held between 6th and the 12th of September, where there will be a sharing of knowledge for resilient, sustainable, and prosperous islands worldwide, covering all of the United Nations Sustainable Development Goals and hosting world-class experts from a variety of fields and a diverse range of viewpoints. I'd like to bring you back on to Renel to introduce the president, to introduce a video of our partners, ASHRAE, Caricom.
Hi, my name is Leah Garner O'Neill, and I am the K-12 STEM champion for ASHRAE Caricom. ASTRA is an international organization comprising of 15 regions with over 57,000 members in 132 countries. Its membership is drawn from a broad cross-section of disciplines, which include engineering, architecture, applied science, energy efficiency, and indoor air quality. The ASHRAE Caricom chapter was formed in only 2018 and now has over 100 members from many of our Caribbean islands. Our programs are beneficial not only to professionals and practitioners across multiple industries, but we also provide opportunities for young engineers and students who are interested in STEM. It is against this background that we are extremely excited about this youth hub and its focus on energy efficiency. I welcome you, and I hope that you have an enjoyable session as you learn more about the energy sector.
All right. Ladies and gentlemen, let's continue. That was a kind word from our partners, ASHRAE Caricom. Now, our goal today is to move the conversation on climate change, resilience, and energy use forward, sparking conscious thought and actionable steps that can change the way we carry about as a society here in Trinidad and Tobago. Today, we have an esteemed panel of presenters, experts in their chosen field, and they will share with us how we can accomplish this goal. We have with us, in order of appearance, Mr. Ignacio R Smith, Chief Executive Officer, SM Solar and Wind Energy Systems, Mr. Adrian R Dwen, Chief Executive Officer of AA Electric Automobiles and Solar Equipment, Mr. Donald Baldeo Singh, Founder, Carbon Zero Institute of Trinidad and Tobago, Ms. Shalini Madhu, Renewable Energy and Energy Efficiency Consultant, and last but certainly not least, Dr. Curtis Budu, Assistant Professor, Utilities Engineering, University of Trinidad and Tobago. Please be informed that we will be fielding questions throughout the entire presentation, as stated by my co-host Renal. We kindly ask that they are submitted via the chat, and they will be answered in our Q&A session at the end. Renal, over to you.
Thank you, Desi. So to get right into this morning's program, I have the distinct pleasure of introducing our first speaker this morning, Mr. Ignacio R Smith, who is going to talk to us about our electricity bills and the costs associated with the energy that we use. Now, as a TNTech bill payer, this is an extremely important topic for me, and I'm sure it's important to all of you. Mr. Smith holds a bachelor's in industrial engineering from the University of Miami. He specialized in management, science, and modeling. After completing his degree, he continued studies in the areas of finance and project management, and also holds a post-MBA. In his quest to make renewable energy available across the Caribbean and Latin America, Mr. Smith and his team are also credited with the development of numerous models and schemes, including grid-tied government-assisted models, zero coupon index bonds, carbon credits, community-based financing, and the optimization of solar electricity delivery using artificial intelligence. Mr. Smith is an active speaker at international renewable energy forums and has an expansive list of speaking engagements that can be viewed in his bio, which will also be posted in our chats. Mr. Smith, through SM Solar, is the coordinating management entity for the Clean Development Mechanisms Program of Activities for the Caribbean and Central America. He was also appointed as the regional contact for the International Solar Energy Society. Mr. Smith's areas of research are in the development of financial platforms and stochastic models to improve photovoltaic availability, grid penetration, and of course, issues of equity and inclusiveness in energy provision. I must also say to you that Ignacio is also part of Trinidad and Tobago's Island Innovation Ambassadors cohort for this year. Now, Mr. Smith, I hand the floor over to you.
All right, well, thank you very much, and very kind for that introduction, and good morning to everybody. Good afternoon, good evening, wherever you are in every part of the world. And I'll start sharing my screen. Oops. Oh, Lord. Having some issues. trying to share my screen. Anyway, well, I will just start by indicating the topic of my presentation and move on from there because we don't have much time. The title, I have titled my presentation, Increasing the Renewable Energy Mix, Managing the Scenarios in the Midst of a Possible Tariff Increase. And I like to start all my presentations with a little slide that speaks about the mentality of some of the utility executive, which is if you want out of the box thinking, you cannot grow up inside of the box, and which is really where we are right now. And one of the reasons why we don't have more renewable energy in the region. That said, why is it that we don't have more renewable energy in the region when we are really poised to have a thriving renewable energy sector? Well, we do have probably comparative tariffs to those that people pay in Europe and in the United States. However, in order to have or to develop a strong renewable energy industry, based on where we are right now with regards to the cost of generating electricity from intermittent sources such as wind or solar. And by the way, in the last auction that we had for solar in Mexico, the cost per megawatt generated came down to approximately $18 US a megawatt. That puts the kilowatt rate at about 1 cent 8, or just under 2 cents per kilowatt hour. That said, why is it that we don't have more renewable energy in the region? Well, it's a multi-problem, it's a multi-dimensional problem. But essentially, you could reduce that to 3 elements. We don't have the income. Most of the countries don't have a legal framework, and in the case of Trinidad and Tobago, we don't have tariffs to support the industry. But unfortunately, we can get away from all that if we think creatively. And that said, we come up with different platforms that can be used to allow the more penetration of renewable energy in the region. See, the problem is that we have to think collectively, and we have to approach the problem from many dimensions and many layers. And we just cannot focus on one single item. One of the issues that I have recorded over the last 10 years, which is how long I have been conducting this research, is that we want to have a silver bullet solution for everything. And that doesn't really play out. So when we look at carbon capturing and sequestration, we look at renewable energy, whether it's in the form of solar, hydro, geothermal, or wind, we think that that is the, with applying a single solution is going to be the way to resolve the problem. And it isn't quite like that. See, we live in a region that is essentially a kilowatt region. And most developers around the world are concentrated in megawatt projects. So that's the first hurdle that we have to overcome, that have a clear understanding of, rather than thinking big and not having achieved anything. Then the second issue is that you have to take into consideration the age of the grid. And for that, you have to do a lot of research, because depending on the age of your grid and whether you have given the grid a lot of support and maintenance, that will determine the amount of renewable energy in the form of intermittent sources that you can absorb. So that's one of the other issues that has to be considered. And then, of course, everybody thinks of solar as being the best solution for the region. Well, newsflash, it's not. And the reason for that is that solar panels are designed to work ideally at 25 degrees Celsius. They don't work well at 32 or 33 degrees Celsius. So when you do your planning to do a PV installation, what normally happens is that you have to account anywhere from 27 to 30% losses on your solar PV system. And based on that is what you're going to be looking at in terms of dispatching energy or generating energy. But now we come back to the nature of the industry. A lot of people feel that this is an industry that is energy generation. Not really. This is more of a financial and real estate industry. So when you are in the financial industry, what do you do? Where do you make the money? Because in one of the reasons, another reason why we don't have more renewable energy is because we don't have the financial products out there that will help the transition. So you, when I talk about financial products, remember, because you are in a sort of real estate business, you have to look at financing of 10, 15 to 20 years. And that in itself, our sector, our financial sector doesn't want to go that long because obviously there are risks involved. So what has been our approach? Well, we have come up with a different grades and different types of platforms to allow a much larger penetration of renewable energy in the Caribbean and Latin America. And what we have discussed with a lot of the financial institutions have been, why don't you increase the term of your home improvement loans? Why don't we look at issuing issuing green and diaspora bonds? Why don't we do an enhanced revolving fund, solar power purchase agreement, have a financial institution create a renewable energy trust fund or community solar, roof rentals, leases, reverse energy as a service, or have a strong grid-tied utility assisted model. With that said, I'll just go into probably two of the models that I've developed over the years. One is the Enhanced Revolving Fund, which is essentially a Pigovian tax system imposed on the people or companies or entities that generate the greatest amount of greenhouse gases. Then you pool all that with all the different Caribbean nations and different countries in Latin America. And I'm sure that doing it that way, you could probably raise anywhere in 5 years to close to $100 billion. And that will certainly help to solve part of the problem. Now, the other model that I have in my presentation is the grid-tied government-assisted model, which is essentially allowing the utility company to take charge of the process of making the transition, and that way you could you'll be able to trying to check my time. That way you would allow a smoother transition and call it something that a country like Trinidad and Tobago could absorb in terms of expenditure. And that concludes my presentation. Thank you very much. And I'll be there waiting for the questions and elements that, any questions that the audience may have. Thank you.
Thank you so much, Ignacio, for your very comprehensive overview of how to think outside of the box and how not to think outside of the box. It was clear from the things that you would have said that there's not one single solution. There are multiple solutions involved. I'm particularly interested in some of the financial solutions you talked about in terms of changes to the terms of home improvement loans. So again, thank you so much, Ignacio, and I'm handing you over to Desi to introduce our next speaker.
Thank you.
Thank you, Renal. Before I proceed forward, just want to remind members of the audience to continue fielding your questions in the chat. They would be taken up and they would be submitted and answered in the Q&A session. Thank you. Now, I am privileged to introduce Mr. Adrian R Dwen, who is a family man with 2 successful children and brings with him a wealth of experience at the executive level, having served as a professional consultant and diplomat for the Trinidad and Tobago government in the oil and gas industry for over 30 years. In this leading role, he has dealt extensively with several heads of government around the world and organizations such as Caricom in the Caribbean, the European Union, as well as other Latin American states. Mr. Dwen is the chairman and CEO of several international companies in renewable energy, gold and precious gem mining, recycling, large emergency inflatable structures, water production, and high-tech agricultural technologies. Here in Trinidad and Tobago, he's the CEO of A&A Electric Automobiles and Solar Equipment Limited, a company that provides fully electric vehicles, solar equipment, and sustainable homes built from recycled materials. In addition, he is one of the consultants for the Net Zero Group based in United Arab Emirates, which is involved with establishing blue and green hydrogen production facilities in the Caribbean, Central and South America. He is the director of MCCE out of Canada, a management consultant company for high-tech firms, and he's also on the advisory board of the Carbon Zero Institute of Trinidad and Tobago. Mr. Dwen has done logistics around the globe as a manufacturing distribution agent and considers his most important contribution to society as being in the forms of a new company which deals with the establishing of a circular economy which provides waste to energy, energy to food, food to sustainability for all, as well as a covenant member of the Living Water Community, which is the UN representative for refugees in Trinidad and Tobago, as well as Barbados. All right, Mr. Dwen will be joining us soon.
And thank you very much, Desi, for your certainly very profound explanation on my bio. And I thank everyone for coming today, all our esteemed speakers, as well as our very growing audience who's here to understand and participate. I'm just waiting on Desi to load the presentation.
Yes, Adrian. I'm waiting the ability to share my screen. Just give me 2 seconds.
Sure. So I'll take this minute to just do a little plug-in for our summit that's taking place on the 6th of September. I hope everyone here will attend Virtual Island Summit, which is coming to us in September on the 6th and running until the 12th. To get into my presentation, just waiting for Desi to go full screen. Lovely, thank you. And what I'm about to speak on today is basically the topic of circular economy. And that circular economy really deals with primarily the differences between what we can achieve from our old system and now our new system of technologies that are available to the world. And you know, while we've always been looking at the wind and the solar, why not let us look at something that's new to reduce our carbon footprint? And this footprint certainly is continuously being added to, because all sorts of new ideas, and there's also the dirty side of renewable. And taking this point into consideration, the dirty side of renewable, let's look at what actually garbage can do for us in that new circular economy. So as we move on into what the story is, we have communities that are presently producing tons and tons of garbage that are now taking up land space to a tremendous extent. And we are producing waste in all different forms. So when we had traditionally just basic food stuff and vegetables, now we have a tremendous amount of plastics, glass, and metals. Our circular economy system that is now available to the world introduces a waste system, as you see here, that's accumulated, and it's a day-to-day situation that can be transformed using specialized technologies that are now available that can actually produce electrical power, and that electrical power can start from the stage of as small as 3 kilowatts and can go into hundreds of megawatts depending on the scale to which it is being produced. That electricity, which can then power our communities and some of our main industries, has a byproduct in this particular circular economy that feeds it into a greenhouse system, again, very specialized, that takes and channels the CO2, which is computer controlled, into an entire system that breeds a hybrid breed of hydroponics, and in turn feeds a aquaponics system, which again, in turn produces food for the entire community. This community is now fed with this system. It's also employed by this system, and the cycle starts back again. So just to explain, we have to go back one slide there, Des. Wrong direction. Right, thank you. First, we start with garbage, as we saw before in the original slide, which is converted into energy. This energy is then used to produce food, and then we go back into the same waste again. We move on to the next slide, which shows the second part of that cycle, which is the actual recycled material that forms a sub-base material that's turned into that energy, and the CO2 from that energy we can turn around and put into the aquaponic system and the hydroponic system to produce food. And again, we go back to the waste, which started off the process. So we go into the third cycle, which is the community then has food and electricity to sustain the independence, which is the second format. The ergonomic self-reliance is then in place because there is power being produced from our waste, And then there's the self-sustainability of the food that's being produced throughout the community. And then we have the enterprise reliance, which is basically the community is now being trained. So we are led to the final stage, which is the total community participation in the entire system, using an educational program that is based on the entire energy sector. Okay, and this energy sector produces zero carbon emissions. It produces its usage of the waste, produces the energy which goes to food, and there's also a water production aspect of this. But finally, and most importantly, what we are doing is educating and training people into a new era of sustainability, buildings and infrastructure that are adequate and long-term, so that the investments are, not short-term at all, and they continue to move forward. So what are the recycling benefits summary? Basically, you have an eco-free system that's generated, so it's no pollution, there's no water consumption for this process, and of course, we will reduce all the landfills that are destroying valuable land that we need. The sustainability is from the generation of the electrical power, which also is separates both metals and glass, and the inert ash, which is producing the new energy that's giving electrical power to the system. So the economics of all this is, first of all, this is a user-friendly system that's deployed in different parts of the world, and it's continuous operation because of the fact that the source material is entirely based on what we are throwing away, rather than what we are trying to generate or dig out of the ground. So the system is modular, as I mentioned before. So it starts off at a very small entity, and we can generate power depending on how it's scaled up. So again, just to show the advantages, there's no pollution while producing the energy. The use of no specific need for separation, so there's no large land space, and there's no water that's being utilized. It's actually water being produced, and the improvement on the whole logistical system, because it's one place that's producing everything. So as we move on, we see that the individuals of that community now have jobs, healthier local food being produced. The community is cleaner with better both air, because there's no emissions or use of the existing water table. Money is being made within the community because everyone is employed. And then for the nationwide, it's independence from food imports, the energy that we may have been utilizing in maybe other islands, and our own natural resources that we can now continue to resell. And then, of course, we deal with the biggest problem that we continue to face, the waste management of our country. Globally, this really encourages a situation where we are presently carbon-free from this process. So the carbon process does not take place at all in this entire process. So as we move on into the last segments, the individuals are now richer and more wealthy due to this process. They're happier and they're healthier. The community becomes totally independent and sustainable because of the fact that the process is utilizing a waste material and not digging into destroying the environment or burning. The preservation of our native indigenous cultures, whose lands are sometimes very much being utilized in this process, can be understood. And then, of course, we have a cleaner environment. And again, just to mention, there's a zero carbon footprint here. So the time is now, and I thank you very much for allowing me to speak. I hope I've not overgone my time, and we are within the short space of time because of the delays of our start. So I hand it back over to Des so that we may have another gracious presenter, Mr. Baldeosi.
Thank you so much for the truly dynamic presentation. Mr. Dwen, it was truly a journey through a sustainable solution that deals with multiple issues that can mitigate against climate change, and increase resilience here in Trinidad and Tobago. Once again, any questions that you guys may have, feel free to put it in the chat, and we will be answering those in the Q&A session at the end of the presentation. Over to you, Renal.
Thanks again, Deb. So this morning we started at solar, circular economy and using that for energy, and now we're back to solar. So for the last few years, the momentum towards harnessing solar energy, it has really accelerated, both in the domestic and the commercial sector. And this morning, we're really privileged to have Mr. Donald Baldeosi here to espouse the benefits of solar energy. Donald Baldeosi is an energy specialist and a social entrepreneur. He's the founder of the technology-based Enman Group and the nonprofit Carbon Zero Institute of Trinidad and Tobago. He has also most recently established a Caribbean e-learning platform as a response to the COVID-19 pandemic, and we congratulate and salute him on that one. Mr. Baldeosi served as chairman of the Petroleum Company of Trinidad and Tobago Limited. And while there, he led the transformation of Petrotrin into a profitable and socially focused national company in the 90s. He served for 10 years on the Industry Advisory Board to the American Society of Mechanical Engineers. Mr. Baldeosi has also chaired numerous conferences on topics such as engineering, procurement and construction, carbon trading, and infrastructure financing. He holds a bachelor's and master's degree in electrical engineering from the University of the West Indies. Now, if you want to learn more about Mr. Baldeosi and his work, you can go to the chat where we'll place some links where you can learn more about him. Mr. Baldeosi, I'm handing the floor over to you.
Thank you very much. Well, I hope I'm unmuted there now. Thank you very much. It's a pleasure to be part of this esteemed panel and to contribute to the discussions today. I was given a few pointers in terms of the areas that are of interest. And if I can share my screen, I can put up something. So I'm sharing now. I hope you could see this. So this is a little bit about CZIT, the Carbon Zero Institute of Trinidad and Tobago. I'd really like to present this, but if it isn't, it's going to go as is. So after Trinidad and Tobago signed the Paris Accord in 2015, some colleagues and I got together and we formed this nonprofit. We took more than a year of stakeholder consultation and discussions before we actually launched it in the beginning of 2017. And we've been really busy and we feel really good about what we've been able to accomplish. We've had more than 500 activities at schools in the 2 years, including in the 4 years, beg your pardon. The National Secondary Schools Climate Quiz, in which we had 2 seasons, a lot of tree planting, a lot of innovative activities around moving into food security and combining that with carbon sequestration. And then we, in the beginning of the pandemic, when all these students were locked up and stranded at home, CZIT decided to go online and meet them where they are. So we launched this online platform. And these are the good people who contribute to it. And we've moved a lot of our activities to online. In the last year, since the platform has been operating, we've had almost 10,000 users, and more than 35,000 times it's been actually accessed and used. And it's providing a lot of content. In fact, it's the most active platform for educational content in the Caribbean. And it's really because of the great efforts of a lot of people, and a process that we use to build an ecosystem of online content. At the moment, geared towards Cape students, but moving into other areas and into other areas outside of school curriculum. For example, beekeeping is our latest addition to the platform. We use a development process that is very robust, and we provide content for exam preparation and other things that the students need, like transition into online. So contact us, have a look at the platform, and let us know in particular how you could help, because this needs a lot of work to continue growing. We are moving our Project Zero online now, which is where students take on activities in reducing carbon, and we have competitions in which they produce a video of their projects, and we judge it by the number of likes on social media. And this, you could imagine, these children love to compete. So we're very excited to launch the first part of this, which is they will make a video saying, I woke up and it's 2050, and this is my first day. So they're going to envisage the world in 2050 and create a video on it. And we're very, very excited about launching that program. So if you're still seeing my screen, I'm going to please jump away to looking at what we're talking about today, and the question of solar, which has been put to me. So the origins of this project in Trinidad and Tobago to bring in about 100 megawatts of solar power. It came out in the annual budget of 2015 is the first time I recall hearing it. And it was this commitment to have 10% renewable energy in the grid by 2021. So we're crossing half, we've already crossed halfway of 2021. And so our commitment was to have 10% renewable energy. Now, the government's approach at the moment is a large-scale solar project, which, according to press, has been awarded to BP Lightsource and others to build a solar park of about 100 or 100 plus megawatts. Because at the moment, our maximum demand is approaching 1,400 megawatts. So to meet the commitment, we need about 140 megawatts of solar. So keep in mind, this is not a Paris commitment. It's not one of the nationally determined contribution elements. It is a project that definitely will result in carbon reduction and will demonstrate a commitment that we are on the road of decarbonization. Another good point is that as long as we use solar or any other renewable energy source to power Trinidad and Tobago, we will be freeing up and reducing gas generation, which is almost 100% of our electricity now is through burning of natural gas. So we will free up gas, keep Point Lisas alive longer, and reduce our carbon footprint. It will also create jobs through the construction and the operation of the solar park. Now, the downside. The downside is that we already have overcapacity in power generation, maybe 600 megawatts of additional capacity to the demands of the country at the moment. If we add solar power, what we will do is increase the overcapacity. And the overcapacity, it comes at a cost. We have take or pay contracts with the generators, which means if you're not using the capacity, you still have to pay part of the cost. And also, we have the capital cost to be repaid of the TGU power station, which costs somewhere in the region of $760 million US. So we'll be paying back for capacity from the capital cost standpoint and through the contracts that we will not be using because we're generating power with solar. The other thing is that if we give up former sugarcane lands, and we seem to be very free about that, into other activities, what we are actually giving up is potential farmland and the ability to feed ourselves in the future. So we have to be really careful about land use changes and moving agricultural land to other uses. So those are the quick analysis factors of the large scale solar. I think that in making this announcement in 2015, an alternative pathway could have been to create a lot more awareness and encourage the use of solar power, even on a domestic level or a commercial level, and start to make the inroads, which would also create the awareness about carbon. And people who put in solar will probably be more encouraged to get an electric vehicle and charge it with the solar, and so on. Now, what's keeping back the solar in general from taking off in the country? So a few bullets here on that. So we talk about the power price. At the moment, Trinidad and Tobago consumers are paying like something in the region of 4 US cents per unit of electricity that we use, per kilowatt hour. Solar does not compete with that. In other words, if you put solar panels on your roof, your payback is going to be, I don't know, 20 plus years at the current prices. Which means that the only people who are putting solar are the ones who are very climate conscious, and I'm sure they spell conscious properly. Or if it's very expensive to connect to the TNTEC system, because you're in a remote area, you have a beach house up in Paria Bay or something like that, you would put solar. But the additional cost you pay to put solar in is very discouraging for most people. So now there are some subsidies to encourage solar. They're not working because we're not getting the increase in the use of solar power. Then we have the elements of the Electricity Act that discourage or make it difficult to have any kind of generation in your home. So people don't generally know, but if you have a standby generator, even a fairly small one, you have to have that license. And in the same way, if you put solar power in your home generating electricity, you have to go through the paperwork. And it's not easily accessible, and it's not straightforward to get that license. So are you breaking the law by putting this solar power at your home? Yeah, probably you are. But is it accepted that it's something we need and people are doing, and as long as it's done properly, it's encouraged? Yes. Now, in terms of properly, we still need to put out and have it formalize the regulations for installing solar and the standards and so on. We don't have that as yet. So we run the risk of putting in solar that could cause trouble. Some years ago, for example, there was a power outage in West Trinidad in a facility, and the TNTEC crew came in and started working on the line. But the facility threw on their backup power generator and fed power back into the line and killed the man on the pole. He got electrocuted and he fell off the pole and he died. But these are the kinds of risks you take if you don't do your solar power properly. you could actually feed power from your system into the grid when the grid is supposed to be dead, say, because there's an outage. And you could cause trouble because also you could be putting low quality power into your neighbor's homes. So there are things that have to be done to get better organized to have solar power in our system. The other point is the feed-in tariff or lack of thereof. So in some parts of the world, if you have a solar power system at your home, during the times when you're not using it, you put power back onto the grid and your meter runs backwards. In other words, you get a credit for the power that you are adding to the grid. That requires legislation to be put into effect and a lot of these other regulations. So we don't have that at the moment in Trinidad and Tobago. We need it. We need to get the feed-in tariff part of it in place. In other words, I could get a better payback for my solar power installation if I can get a credit on the rest of my electricity bill when I supply power back onto the grid. And that would encourage, that would bring the payback period down and make it more interesting as an investment. In the meantime, there are lots of people who are very interested in reducing their carbon footprint. And there are ways, and there are people who are supplying. There's a company called Rescut. I'll put a little ad for them because I think they're doing a great job. And of course, Mr. Adrian Dwen with the Tesla Powerwall systems. There are very good quality alternatives available to put in some solar power and to take a responsible action in terms of your carbon footprint. The other thing that I strongly recommend, and I don't see enough of, is putting a solar water heater. The payback on a solar water heater is much better. It's not using solar photovoltaic cells, but it's actually directly heating the water from that hot sun. Yes, it was raining heavily this morning, but that sun out there is scorching at the moment in South Trinidad. Our solar water heater that we've had now for more than 10 years. If electricity goes right now, I can go and open that up and make tea directly from it, from that water in that solar water heater. So let's roll out solar water heating. It will reduce the amount of electricity we use for heating water. We'll save money on our bill, we'll pay back fairly quickly, and we'll have something that is available to us in times of an outage. You still can have hot water available to you. So those are the things I'm thinking of in terms of the points that were put to me. I was also asked to define the levelized cost of electricity, and maybe I'll do that by just moving on a slide or two down this presentation. Here we are in Trinidad and Tobago, balancing all sorts of things. We're standing precariously and juggling many things that we need to grapple with to put our economy on course for a sustainable future. Think about the last 100+ years when the economy moved from cocoa and coffee based to sugarcane to oil, and oil was the first commercial oil well on land was drilled in Trinidad and Tobago. We claim that in the early 1900s. The economy moved to being supported by oil, and then somewhere in the mid-1990s, gas took over as the leading mainstay of the economy. We are definitely, without doubt, heading to the end of our gas industry and our oil industry. Production is reducing. Point leases companies are receiving something like 20% less than their contracted gas because we don't have it in sufficient quantities. And the world is losing its appetite for hydrocarbons. So we are at a stage, people on this group meeting, where we have to define a new future. for Trinidad and Tobago. And that future is available to us right now if we take the right actions today. Not tomorrow, not next year, not 20, whatever. Today, because we're already late. And we are late in transitioning the country to a lower carbon, sustainable economic situation. We are late on keeping commitments we made under the Paris Agreement. In this year of reckoning in a way for climate change, when the countries of the Paris Agreement, the COP countries for the Paris Agreement meet in the UK in November, everybody is going to have to stand up and be counted. What have you done since 2015? So, yes, it's a short window to get some things at least started, but let's get started. Let's have a better picture. Because after 100 years of producing carbon, we have the opportunity to reduce carbon even as a mainstay of the economy by having the right research and the right activities. I don't know if I'm running out of time, so let me just put up this slide.
You're in your final few seconds, Mr. Balio Singh.
In these final few seconds, I present a very complex map of the Caribbean, where I'm showing that in the southern areas of the Caribbean, there is enough hydroelectric power to provide the base power for the whole of the region between Guyana and Suriname, but they are also now oil producing countries. In the Northern Caribbean, you have a big demand for power and a certain amount of renewable energy coming up. Along the Caribbean island chain, you have great potential for geothermal energy. And everywhere you have potential for wind and solar. And right in the middle of this universe of energy, you have Trinidad and Tobago, who is able, because we have surplus, we have liquidity in the system here, meaning there's money to invest. We have a long, rich history of technical project development and execution, and we still have influence in the region. We can help to develop the geothermal, to develop the hydropower, and to interconnect them so that some countries generate power, some buy and consume power, and everybody could develop their wind and solar. And the hydropower in Jamaica, Guyana and Suriname becomes the batteries in this system. So you run your wind and your solar during the day, and you run geothermal as base power. And you bring in your hydro when you need it at night and other times, and you kick in your gas generation when all of that is falling in. I'm closing up there, but I'm able to answer questions later.
Thank you so much, Mr. Balio Singh. I'm so sorry we had a mix-up at the end there, so we were not able to see your map. So if it's possible, maybe you can share it in the chat so that we can all have the benefit of that map. It sounds quite interesting. And I definitely have to thank you for the clarity that you brought to my mind, and I think the clarity that you would have brought to the entire conversation. I think you showed us the numbers in terms of where we are at and where we need to be to achieve that 10% renewable energy target. And you've also talked about some of the many things that we need to do going forward, whether it's the solar water heaters, some of the legislative changes that we need to make. So we really love to explore those issues in our question and answer session later. So I now hand you over to Desi to bring in our next speaker.
All right, fantastic. Thank you, Renelle. Now I have the distinct pleasure and honor of introducing Ms. Shalini Madhu. Thank you. Holding an MSc in Renewable Energy Technology, Ms. Madhu is a Trinidadian energy engineering consultant whose goal is to improve environmental sustainability primarily through energy efficiency and renewable energy approaches in the Caribbean. She is a proud member of the Clinton Climate Initiative's Women in Renewable Energy, also known as WIRE network, where she mentors other professional women in the field and sits on the WIRE selection committee. Ms. Madhu has worked on and led several energy efficiency and climate initiative projects in both commercial and industrial sectors across the Caribbean, including Trinidad and Tobago, St. Lucia, Antigua, Grenada, and Dominica. With 5 years working experience in conducting ASHRAE levels 1 and 2 energy audits, performing whole building computer simulations, managing energy efficiency projects, conducting energy management trainings, and engaging in stakeholder proceedings. She was given the opportunity to moderate panels at the Caricom Renewable Energy and Smart Grid Conference and Trade Show in Miami. While residing in Barbados, she is presently working as a technical consultant on the Interreg V project for energy transition in the Caribbean under the topic of energy performance study of tertiary sector building in the OECS member states. Under this project, she is spearheading all energy-related activities for Dominica, Montserrat, and Grenada, whilst assisting the other 6 member states. Without further ado, we now have Ms. Madhu on the floor.
Thank you, Desi. Okay, great. So you all hearing me properly?
Yes, we are.
Yes, perfectly.
Great. So today on my agenda, I will be discussing energy efficiency in TNT, steps to becoming energy efficient, and just provide you with 2 case scenarios. So just some housekeeping on some energy terms. People tend to mix up energy efficiency and renewable energy. So renewable energy is a type of energy source, whereas energy efficiency is using a technology that requires less energy to perform the same function. Energy conservation, on the other hand, deals with your behavior and practices of using less energy, which is like turning off lights. Energy management incorporates both energy efficiency and energy conservation in order to process of tracking and optimizing energy consumption. So you can use this by using a building management system. Why do we want to be energy efficient in TNT? Well, first of all, we will help TNT with its ratification to the Paris Agreement, in which it states that we are trying to reduce our overall emissions by 15% by the year 2030. In turn, it will strengthen our independence by improving energy security, reducing our dependence on fossil fuels, and creating a more resilient power grid. As for energy companies, they can now lower their fuel costs, which can then have savings that are now passed on to all consumers. And for people, it means reducing your energy bills and freeing income for other expenses. So for those of you who didn't know, if you lower your electricity consumption, you can get a 25% rebate on your bill that is less than $300 TT. You can refer to the TNTech website for more on that. Also, you will be improving your air quality because burning fossil fuel at power plants release particles in the air causing respiratory illnesses. It may not affect you, but it will affect the persons that are around it. So steps to becoming energy efficient. There are 3 ways. How do you become energy efficient? You have to first know your consumption. And in knowing your consumption, you can get that from your utility bill. And next, you can identify your large consumers by conducting an energy audit. Now, there are 3 levels of ASHRAE level energy audits. A level 1 is just a walkthrough where you just note your power values of equipment. A level 2 deals with an inventory and metering where you use data loggers and 3-phase power analyzers. And a level 3 is where you do computer simulation for whole building modeling. So that's where you can model an energy efficient building. Next, you have to conserve the energy that you just found out you're using. You're doing this by practicing low consumption behavioral habits, which I will discuss further on, and by purchasing energy efficient technologies. And lastly, you have to keep track of this consumption so that you will know if you are on the right track or if you are what we call lapsing. So in order to do this, you can keep the records of your electricity bill, please note the consumption and the cost, because in time to come, your consumption may stay the same, but your cost is going to improve. And you can also use energy meters and data loggers to also keep real-time track of your consumption. A quick way to know your consumption at home is to just know the power value of your equipment, and then you can estimate the number of hours that these equipments are on for the day and the number of days for the month. So just a quick example here, I would have taken a simple television at 75 watts that's running for 5 hours a day, 30 days a month. That in itself is equivalent to 11 kilowatt hours, which leaves behind a carbon footprint of 12 kilograms. And you can see I have used my carbon footprint equivalent of 1 kilowatt hour is equals to 1.07 kg of greenhouse gas emission. So now you can use the simple equations and formulas above, and you can all find out what your consumption is and what your carbon footprint is. Pardon? Okay, yeah. Up next, this EPA has a nifty tool that you can use, and you can get your equivalency with your electricity consumption and your carbon footprint. So instead of using abstract measurements that you don't know what it means, your EPA calculator will now relate it in terms that you understand. So for this example, I would have done a household using 1,000 kilowatt hours a month, and that is equivalent to using approximately 70 gallons of diesel. The website is below, you can always check on it. Next, conserving energy. So there are no cost or behavioral changes, and these are easily accessible. So you can get this by turning off your equipment and your lights when not in use. You can hang clothes on a line instead of using your dryers. You can do temperature reset on your AC units. And by that, I mean, I know a lot of people tend to put their AC setting somewhere between 16 to 20 because they're trying to cool as fast as possible. But based on our climate, your temperature should be between 22 to 25 degrees C. Anything below that is going to put added work on your compressor. In that way, it burns more electricity. You can use natural lighting by opening your windows. Of course, when the AC is not in use, because I've seen people use their AC as well as have windows open. You can delamp. A lot of places, in commercial places especially, they have too much lighting. So when you conduct an energy audit, you'll realize that your lighting sometimes is like 15 to 20% more than what is necessary. Overlamping will definitely cause headaches and eye problems. You can also activate your sleep setting in office equipment, such as your printers and computers, because especially in the public sector, they are very reckless with how they use energy and their behavioral habits, and they tend to leave on these equipments after working hours. Some low-cost investments. You definitely have to perform routine maintenance on your equipment to ensure that they are working properly. You can install dampers and seals on your door. In this way, you know that your cool air isn't escaping and hot air isn't coming into the room. And the dampers will definitely make sure the door is closed, because in commercial places especially, people tend to open doors and do not close them back behind them. You can install programmable thermostats. There are now Wi-Fi thermostats. So in the event that you forget your AC on, you can always turn it off using an application on your phone. Install seals, tins, and blinds on your windows. This in turn reduces your solar infiltration within your air-conditioned space. Install occupancy sensors in your homes, bathrooms, and offices. So what this does is whenever a person enters a room, your lighting will come on. As soon as they exit, the lighting will shut off. So in that way, it leaves the memory and the actions to the sensor as opposed to you having to remember to do it on your own. You can also utilize load sensing power strips. What this does is that everything that's connected on the strip, whenever it senses that an equipment is on standby mode, it shuts it off. And you can also have a roof garden for those of you who have a flat roof. Some capital intensive investments are to retrofit your existing lights into LED lights. You can retrofit your conventional mini split unit into an inverter type AC unit. You can install a food simulator in commercial fridges. What this does is that it mimics what food you have in your refrigerator and it cools it accordingly. Because sometimes we have chicken and vegetables in the same one and you don't require freezing for both. You can install soft starters on those of you who have compressors to reduce your inrush current. You can install variable frequency drives on pumps and air handler units. In this way, you are using less power at the same RPM. You can purchase Energy Star products. Very important. Whenever you're purchasing equipment, look for that Energy Star sign. It means that that product has a lower energy than regular products. Be sure to insulate your roofs, the most common spray foam. This in turn will reduce the amount of solar infiltration into your space as well. It's common in the Caribbean that a lot of people don't insulate their roof and you have a lot of leaks. Also insulate your ducts, the most common are duct wrap and fiberglass, and install double pane glass on windows as well to reduce that solar infiltration. Just some mindfulness, seeing that air conditioning takes up approximately 50% of your electricity bill. Correct sizing of your AC is definitely important. Some people tend to undersize their AC, and in that way, the AC has to work extra in order to cool your room without shutting off. And there's an instance where you oversize an AC, meaning that your input current is definitely higher than what it should have been. Maintenance is key. We tend to take this for granted, but be sure to clean all your filters, ensure that there are no leaks, and please insulate your refrigerant pipelines. Your condensers, which is the outdoor part of your unit, it should be placed in a dry area where it can freely breathe. Proper ventilation is key, away from dust and trees. And ideally, if this could be placed on the north side of your house, that would be great, but the east side will do as well. You see, in areas where it's covered or has less exposure to the sun, the AC doesn't have to work as hard to cool the air around it before blowing it into your home. And as I mentioned before, just a quick difference between a conventional AC and the inverter. The conventional AC works at a constant speed compressor, meaning that it cycles on and off continuously, and it can be noisy and has a high power rating of values of 1.2 kilowatt per ton. 1 ton is 12,000 BTUs. An inverter AC, on the other hand, it has a variable speed compressor. So whenever you turn on your AC, it ramps up, but as long as your desired set point temperature is met, it goes down and it maintains there. This is especially better for units that are on all the time, such as in libraries or server rooms. They are less noisy and they definitely have a lower power rating and values of 1.1 kilowatt hour per ton. I just did a really quick case scenario here, seeing that a lot of households and commercial buildings, they have a lot of lights and AC. So I just did want to retrofit an incandescent bulb, a 60 watt, into a 5 watt LED bulb. And you can see that lighting retrofit has a 92% energy saving. And from retrofitting a 12,000 BTU AC conventional to an inverter has a 32% saving. Now, if this running hours was increased, your savings will definitely be greater. Major takeaways, just remember that using electricity generated from non-renewable sources definitely contributes to global warming and climate change. And energy efficiency is your responsibility. At the end of the day, we are all blaming the governments for not helping us in direction, but the availability of the products are there for you. Proactive in becoming energy efficient before electricity rates and costs of living increase. This is those electricity costs is not going to be subsidized forever. Be the driving force that your government needs to support in order to add more in their citizens moving in the direction of being energy efficient, adopting their policies and moving forward with your legislation. And a piece of advice for you is to target energy efficiency and energy conservation before you target renewable energy. The thing is from the grid, but it's still maintaining your existing consumption. Energy efficiency, on the other hand, when a reminder as to why all of this is important. Just think about the future generations, the quality of life you want them to have. So if that's a life, security, and better environmental quality, I will not pave the way for them. I thank you.
Thank you so much, Ms. Shilling. It was truly, in some cases, an educational when it comes to some of the information you would have shared. You know, it definitely makes me need to get that, as well as bringing to the conversation of having automated equipment where possible to really achieve a holistic approach towards reducing our carbon dioxide and other greenhouse gases emissions. That being said, questions, we are still to encourage questions. We have a fantastic panel here doing a marvelous job of bringing really issues to light. That being said, put your questions into the chat box. We would answer those at the end in the Q&A session. Renel, over to you.
Thank you, Desi. Our final speaker this morning has a wealth of knowledge and a wealth of experience. I think he's well equipped to make links between our petrochemical usage, natural gas reports, and of course climate change. So I'm going to use the cliche, but please forgive me. But last but certainly not least up, we have Dr. Curtis Boodoo. Dr. Boodoo holds the position of Assistant Professor in the Utilities Engineering Unit at the University of Trinidad and Tobago. He has been a faculty member at the UTT since 2004 and program coordinator for the Electrical Electronics Engineering Diploma at the John Donaldson campus since 2008. He developed and currently administers the first dedicated renewable energy engineering technician level program. Now that's a mouthful in the Caricom. He was the project manager and is currently the chairman for the Electric Vehicle Work Group in Caricom, a position he has held since 2017. He is the consulting engineer for the United Nations Development Program in Trinidad and Tobago and oversees the design and construction of 12 community photovoltaic installations. He has served as the Community Climate Change Center, the Inter-American Development Bank, and the German organization GIZ, a development agency that provides services in the field of international development cooperation and international education work. He's also worked for the government of Barbados and the Federation of St. Kitts and Nevis. Now that's a quite impressive resume. So for more on Dr. Boodoo's background, we will provide some links in the chat. So let me hand the floor over to Dr. Boodoo and you can begin.
Thank you very much, Renel. I hope you could hear me clearly.
Very clear.
Okay, great. So as Renel mentioned, I was given a very easy task this morning. In fact, I believe I have the easiest one, to connect natural gas, the petrochemical industry, and climate change. So my approach this morning is one where I will focus on the well here in Trinidad natural gas. Natural gas feeds into our petrol in the mix. And in the power generation sector, we have to have a greater share of renewable energy. And I think Donald mentioned about the plans for solar. But a lot of what I am saying, he actually touched on as well. There should be a focus on a feed-in tariff. This feed-in tariff is for solar in the domestic and light commercial setting. And there should also be a feed-in tariff that focuses on the technology of wind for agriculture and also light and commercial. One of the projects I'm involved in with the UNDP, we currently have a consultant that is in the final stages of producing a feed-in tariff for the Ministry of Energy. So this is something that we expect to be out soon. I've noted, I'm aware that's a comment that's made very regularly, but hopefully we would have a feed-in tariff for Trinidad and Tobago, a very soon approved one. At the utility scale, we of course have the planned 112 megawatts of solar. It is my personal opinion, this is going to be the first and only utility scale solar PV installation in Trinidad and Tobago. Why? Well, we genuinely don't have the land space. This installation, which is close to the UTT Point Research Campus and also in Trinity, it's split into two. It's taking up a number of hectares. So it's unlikely we will have a solar PV utility scale project of this size in the future. Again, that's my opinion. If you look at onshore wind, we belong to a low wind regime here in Trinidad, but you could find pockets of high wind resource, especially as it relates to the natural topography. So if you are a farmer or you have a business and you live in a location that is a hill, that is hilly, then of course you could benefit from some speeding up of the wind at the top of the hill. So you can use onshore wind at certain locations or at certain topographies or localized locations where it is beneficial. Natural gas will continue to be a part of our electricity generation now, short term and maybe the long term. There are some challenges as it relates to 100% renewable energy generation. Renewable energy is a variable source. And because of that and the fluctuations in its generation, it causes certain power system instability. And this is why you would need energy storage. A nice way to get around that, provided we have natural gas in the future, is to continue to use natural gas to support your renewable energy generation. So I see natural gas being part of our short-term, medium-term, and possibly our long-term energy landscape. Offshore wind, I believe, is key. Why do I believe it's key? Unlike solar, our exclusive economic zone offshore is large. The surface area is large offshore. And we have around 2,000 megawatts or 2 gigawatts of installed capacity in Trinidad. And if you want a large percentage of renewable energy or a significant amount compared to that 2,000 megawatts of power, then you're going to have to invest in offshore wind. We just don't have the on-land or the onshore speed to reach such a high percentage or a comparable amount of that 2,000 megawatts of installed capacity. Again, if your goal is to green the petrochemical industry, if you want to make green ammonia, if you want to make green methanol, then you need a large enough green energy source. We're not going to get that from onshore solar. We're not going to get that from onshore wind. It can only come from offshore wind. The power we require to green our petrochemical industry is going to be a large amount, and that space is offshore. The available land we have in Trinidad, as Donald rightfully mentioned, should be preciously looked at for agriculture and housing. And it is very difficult to commit land for energy production at this time. So this is one of the reasons why we need to, I would say, seriously look at our offshore resource. So we can't discuss energy without discussing transportation. And you should never separate both of them. That's the old way of thinking. Because we have electric vehicles, that means that electricity is now your transportation fuel. And I wish Tech would realize that they are now in the transportation fuel market more often. So it's a new field and it's something that needs to be exploited. So, and transportation is a major source of emissions for us, not the highest source, of course, but I believe it's a low-hanging fruit. So the goal is to electrify all transportation in Trinidad. That should be clear. Electric vehicles is where we should be going. It is our destination. CNG is the transition to EVs. Just like we have a transition from fossil fuel to renewable energy, CNG represents that transition to EVs. People say we have 1 million vehicles on the roads in Trinidad. We probably have less than 100 fully electric vehicles in Trinidad. So most of our vehicles are ICE or internal engine and combustion engine vehicles. How do we clean them? How do we get them to use a cleaner fuel? They are in Trinidad, they're going to be here for a prolonged time. Vehicles are kept in Trinidad for a long time. So you may own a vehicle and sell it after 5 years, but it is still kept in use. So we need a clean fuel for these ICE vehicles. There's a lot of talk about hydrogen in Trinidad. Let's please not talk about it in the transportation sector. It can do a lot of benefit in the petrochemical sector, but I don't see hydrogen being applicable for us in the transportation sector. We could discuss this later on in the panel discussion if you like. We need to focus on public transportation. If we have a safe and reliable public transportation, people will not jump in their cars and drive themselves to the destination with them alone in that single car, which is inefficient. And it is important for a focus on public transportation. And we also need to put in the infrastructure to encourage non-motorized forms of transportation, especially within the cities of Port of Spain and San Fernando. Invest in the infrastructure for safe sidewalks and bicycle paths, and you encourage people to do that within the city. And this holistic look at transportation will not only cut our emissions, but it will also address the health issues we as a country face and the Caribbean region face. So what's my pathway to the future when we have to try to keep our petrochemical industry going, deal with natural gas curtailment, and still try to meet our climate change commitments? So number one, I would want to say is partnerships. We are falling short of natural gas in Trinidad, but we have neighbors that are not falling short. In fact, every day I read a new discovery. So partnerships are important for us. And I think everybody would say, well, you know, we done in Guyana and we done in Suriname already. But I would like to say that there is a perception in Guyana and Suriname that Trinidad's approach to them has been aggressive and at times condescending. We treat our Guyanese and Surinamese neighbors as our little brothers and little sisters when it comes to the oil and gas sector. And that is something we should not do. This was something that was said to me by high-level energy persons in Guyana and Suriname. And when we approach Guyana and Suriname, as it relates to energy, we should have a holistic approach, meaning that our Ministry of Energy, our Ministry of Trade, our Ministry of Foreign Affairs, they're all in sync. You can't have persons in different pockets approaching Guyana and Guyanese businesses alone. So we need that holistic approach, Guyana and Suriname. So we need to look at a long-term strategy on how do we enter into partnerships with Guyana and Suriname, and it must be a holistic strategy. They could address our natural gas curtailment and we must work towards it. Number two, I would say, is to adopt a more end of use of natural gas approach. What do I mean by that? There are private sector American companies that are getting involved in natural gas in Caricom. In Jamaica, there's New Fortress. New Fortress has a regasification facility offshore in Jamaica. And Jamaica is now bringing natural gas onshore for power generation, and they have CNG buses. In the small island of Antigua, another American company, Eagle LNG, I think they are called, they are setting up a facility that would allow for natural gas to come onshore in Antigua to power, I believe it's a 5 megawatt power plant or thereof. So these are opportunities I look at, and I'm not seeing Trinidad taking, well, at least publicly or for the information I have, I'm not seeing us taking up these opportunities. So what I'm saying is we have to look at the end use of natural gas and not only look at selling natural gas or getting a wider market for it. The end use of natural gas for our small island colleagues and is in power generation. So you go to them and talk and open a conversation on power generation. And look how you could facilitate them switching their diesel power generation to natural gas and see how we can assist that. And of course, be the source of that natural gas. Number three, I would say, is human resource. We belong to a single market economy. In fact, one of the oldest surviving single market economy in the world, Caricom. But there's a lot of bureaucracy for Caricom National to work from one island to the next. Trinidad needs to lead when it comes to trying to reduce and simplify the bureaucracy for Caricom nationals, especially Trinidadians who are hydrocarbon professionals, to work in Guyana and Suriname and other small islands that are interested in investing in hydrocarbons. So this is something that needs to be addressed, and we must look at also nurturing small businesses or businesses that are involved in the oil and gas sector and helping them to extend to the wider region. We have to look at upskilling as well, and I must say the universities in Trinidad, both UTT and UE, do offer renewable energy programs. But I would like to say that the focus should not be at the postgraduate level, but at the technician level. You need these practical technicians to be the ones to come and install solar on your home, on your roof, or on the roof of a commercial building. And this is an area that we need to focus on. Lastly, I would say we have an absence of two major policies in Trinidad. We don't have an energy policy, which we shouldn't be calling it an energy policy. It should be a sustainable energy policy, by the way. We don't have a transportation policy. Again, that should be a sustainable transportation policy. But we also have the opportunities to put a lot more forward-looking policies as it relates to integrating with the Caricom market and the natural gas and oil and gas that we expect to come out of Guyana and Suriname. Somebody once told me that whenever you're looking at the energy landscape, you cannot fully ignore the sleeping giant that is Venezuela. Yes, there are challenges in Venezuela, but I don't believe those challenges will be there indefinitely. And that is a direction or opportunity we should look at. So we should look at some long-term energy planning. And when we look at energy planning, we need to also dive in deep into the technical aspects and look with rigor. So we invest the technical we look at the technical aspects and also future market growth. So that's it for me. Thank you for listening. I hope I was able to try to connect natural gas with the petrochemical industry, try to talk about climate change, yet keeping our focus in natural gas, yet keeping our core business in natural gas open, but trying to be clean. Thank you very much.
Thank you so much, Dr. Budu. I think you did an excellent job at linking all of those things together. And of course, you gave us many areas to explore in terms of policies around sustainable transport, policies around land use, and of course, policies around our human resources and how we really exploit that to the full capacity. So Desi, let me hand it over to you.
All right, we are coming down to the end of our presentation, but I wanted to take some time to just quickly share a wider picture moment. Climate change is a real and present danger, not only to Trinidad and Tobago, but to the entire world. In fact, the Intergovernmental Panel on Climate Change, which is the IPCC, had a report on climate change in 2021 that states many changes in the climate system become larger in direct relation to increased global warming. It even goes on to say that continued global warming is projected to further intensify the global water cycle, including its variability, global monsoons, precipitation, and severity of wet and dry events. One just has to look on to recent events such as Hurricane Ida, extreme drought in Madagascar, and the ravenous wildfires in Australia to know how much natural disasters has no boundaries. Now, it is our duty to not only speak about, ways in which we can mitigate these extremes in temperature or adverse environmental effects, but to also find ways in functionally and actionably implementing what we speak about. That being said, We are now going to open up the Q&A session, and Renell will lead us off with the first question. Renell, back to you.
Thank you. So our first question is for Mr. Baldeo Singh. So you mentioned many different forms of energy that we can explore in the Caribbean. So someone asks, what about the generation by wave as an alternative energy source for the Caribbean?
Generation by wave. I think that it will come into play at some point, but I feel that we need to take a much more practical approach at this moment and go after the lowest hanging fruit. So in terms of where wave energy would come in, ahead of that, excuse me, is hydroelectric power, geothermal energy, solar power, and wind power. And after we start to maximize the potential of these, then we will get into wave generation, and there's more than one form of ocean type generation, and other forms of renewable. But let's go after the ones that are most easily available, is my opinion.
All right, thank you, Mr. Baldeo Singh. Is there anyone else on the panel would like to chime in, or can I move on to the second question?
I'd like to say something on that. There's while wave technology, as Donald mentioned, is sort of lower down on the list of priorities. I would say that its development is still very early, while all the other industries have already proven itself. So I think that, from that respect, for Trinidad and Tobago, we'd really not want to be in a position of trying to be the catalyst for a direction that's not really in main focus at present. So I think that, alternatively, just to go back to the issue that we discussed earlier, I think that waste energy is one of the more critically and more developed sectors that are taking place. And I think that wave would fall a lot lower in the scheme of things. So that's just my little comment, yes.
Thank you for that, Adrian. Since you would have mentioned your circular economy model, so there was a question in the chat. How long does it take to offset the cost of the system? And are there any annual estimated ongoing maintenance costs?
Okay, so sure. The offset on this case is dependent on the community and the amount of garbage that's being processed. Because while the energy generation is a main issue with waste energy, it is the other sides that are more specialized. The agricultural sector that creates an independence from foreign exchange, from the actual food sustainability. So if you want to calculate the cost, in this particular case, it is immediate, because you are putting back money to where money would have been normally spent. So, if you reduce your food import bill to zero and you start focusing on export of then your agricultural system using the waste energy and the waste circular economy method, you will find yourself paying back for your system in a very short space of time. And that short space of time is all dependent on the commitment of a particular government to do so in a more large scale way than continue with its present system of use. As far as the maintenance cost, presently the models that are being run in other parts have seen a very low maintenance issue of under 15% for the actual equipment, and this is the generating equipment. However, things like the specialized greenhouses have maintenance of almost zero. The blockchain technology that's computer controlled for the greenhousing system that generates the food has almost, I would say 20 to 25 years of technology behind it already. So there's actually zero there. The final issue, it's only what is the volume of, again, product being processed. Remember also that I may have mentioned in that presentation that there are sub filtration systems that give you both glass and metals separating automatically from this process, which gives you additional revenues to generate from the waste itself, rather than only looking at the electrical side.
Thank you so much, Adrian. Well explained as well. Are there any members on the panel have any questions to further what Adrian would have shared with us? All right, well, if not, I'll be going straight into question for Ms. Madhu. All right, I'm seeing here, this question might be, are there any issues from the harmonics that may be introduced from VFDs? Ms. Madhu?
Well, a lot of harmonics in the system, which I assume would be more in the commercial sector as well as the industrial sector, those in turn will affect your power factor. And with a lower power factor value, you therefore have a decrease in your supply as well as an increase. You can also achieve savings with a better power factor by using capacitor bands. So with the introduction of more harmonics in a system, it will reduce, it can affect your power factor value. I hope that answers the question.
Yeah, Desi, I would like to add to that question as
no
well.
issues. Feel free.
Yeah, so I would say from what I've seen, most of the equipment would meet the IEEE standards as it relates to total harmonic distortion. We will actually ask this question with the bus, the electric bus, whether or not the charging, which is a nonlinear effect, would bring about harm. Would meet IEEE standards as it relates to total harmonic distortion. And the manufacturer will ensure that it meets those standards. So you should be safe once you use one of these reputable brands. Thank you.
All right, thank you, Curtis. I have a follow-up question for you. And I know Rena will go after. When it comes to natural gas, I'm not sure if this is within your expertise, but how long do you think we have? Might be a favorite question. How long do you think that we have? How much reserves is there?
I don't know. I just ask people that question and they just say they don't know. People who know more than me. I don't know. 10, 15. Donald is probably the guy to answer that. He's better connected in these matters, but probably 10, 15 years. I don't know.
Thank you.
Sorry.
Understood, Dr. Budu. I'm going to keep you on the floor and just ask you one related question. You talked a lot about partnerships, particularly with Guyana and Suriname. Do you think that if our government enters into an agreement with Guyana, that would be one possible way to keep our Train 1 plant running and save on some costs?
Yeah, I saw that question from Karen. Excellent question. Politically right question as well. I would say we have a difference in timelines, actually. The Guyanese are now finding natural gas. So, you know, I believe we have already invested in the repairs on Train 1 already. So, you know, there's this gap or timeline before we could actually get something from them for Train 1. But I guess the theme of the question is one that whereby we can most definitely benefit in the future. from Guyanese, future Guyanese natural gas. Most definitely, we could benefit from the oil finds that they currently have. So I believe that there's still a gap in terms of getting natural gas from them to Trinidad that may not really benefit the investment we already made in Trinidad. But again, there may be persons on this panel who would know more than me.
If you like, I can jump in. So the 2 points about gas. So we annually do an estimate of how much gas we have left in the reserves, and it's set up as proven, probable, and possible reserves. And then we look at the current consumption, and then there's an estimate of how many years of gas is left. And it's very misunderstood because what the Ryder Scott report, which we normally go to get, says is that we have less than 10 years of gas remaining. Now that means that if we take all our available reserves and convert them into use the way we're normally using gas, it will finish in 10 years. However, that really does not happen in a practical sense. First of all, the gas is not like a big pipe that you turn on and then you turn it off after 10 years. It will go through a depletion model, and over a very long period of time, it will go to zero. And what that normally does is it prompts exploration activities that adds more reserves. The thing with us is that our new reserves are not coming in at the rate that we are using up gas. So we are compressing the time, and the curve towards zero is happening very rapidly, which is why you have plants closing down that would normally use gas. Now, the Atlantic LNG Train 1 was one of the biggest users of gas in the country. And to keep it running from Guyana gas, just to continue the point from Curtis, is that the Guyana is mostly producing oil and is producing a certain amount of associated gas, which is currently being flared at a big carbon cost. And Guyana is looking to bring some of that gas to shore. It's a long way offshore, it's expensive, and it's only available in a small quantity at the moment, which Guyana has plans for. So we should not be thinking about gas from Guyana at this time.
Thank you, Mr. Baliosi. All right, we have a question for Mr. Ignacio Smith. Can you tell us a bit about how the cost of solar energy compared to the cost of non-solar or non-renewable sources of energy?
Okay, well, I'll start by saying that the cost of solar is broken down into 5 elements or 4 elements. Then you have electrical balance of system, then you have the mechanical balance of system, then you have your soft cost, and then you have some other costs that I cannot remember right now. But anyway, so what we do is that we compile all that information, and we work out an internal rate of return based on the size of the project. And normally, a project will have a 20-year lifespan, but what you would usually do is you would make a cutoff at year number 10. So if at year number 10, you have an internal rate of return that beats whatever the commercial market rate is, which is what probably the savings rate, the average savings rate that you have, then you know that it is a good project. Now, the formulation for the levelized cost of energy is a little bit more complicated than just taking up the information and working out the internal rate of return of the project. However, when you come up with the levelized cost of energy, whether industrial or commercial, or whether it is at the wholesale price, because remember, you have a wholesale price, and then you have a commercial tariff, industrial tariff, and domestic tariff. when you work that out, then you realize, well, okay, my cost of producing the energy is now higher than what I'm currently paying based on different types of formulas that you work out. So that is where you have to make a decision whether it is feasible for you to install a solar PV system or not. In the wider region, meaning Latin America and the Caribbean, because the domestic tariff is so high, we're looking at an average of about between 30 to 35 cents a kilowatt hour. It makes perfect sense because the highest cost that you will have to generate electricity, whether it is community solar, a domestic installation or an industrial installation, is probably around 18 to 22 cents a kilowatt hour. So at the end, if you work out the math, you'll say, okay, I'm going to be saving 10 cents per kilowatt hour for the power that I'm going to be generating. That said, you have to also consider the fact that these rates do not include a battery bank, because if you have a factory and you have to run your factory 24/7, it means that you're going to have a battery bank, and that would add significantly to your actual levelized cost of energy.
Thank you so very much.
Does that answer the question?
More than most certainly does. Thank you
Okay.
for the comprehensive reply. Renel, on to you.
I will ask one more question that was directed to Adrian. Do you have any thoughts on the use of methane generated from landfills for energy?
Yeah, the methane idea, while it is an excellent idea, it still has not really come to the forefront to be a useful enough power generation. While the waste aspect generates a fuel and subdivides the raw materials that are putting from the waste, separating glass and metals and producing a fuel substrate. So just trying to get methane from the garbage is one particular process, but there is a synthetic gas that is already being produced from that waste to garbage, the garbage to waste process that we were explaining. So yes, there is some use and thoughts on that issue, but our system already creates a synthetic gas that's a fuel that's providing that electricity from the system.
Thank you so much, Adrian, for that response. Desi?
I would like to add something to Adrian's response. There is something called metal organic frameworks. They have been in existence for probably about 2 or 3 years now. And a metal organic framework actually acts like a filter. So the sink gas that is being generated by the burning of the waste to generate electricity can actually be separated into hydrogen, carbon dioxide, carbon monoxide, and methane. And you can have call it a liquefying process where you can obtain the separate the gases and then liquefy them for sale. But again, that is not is a technology that has been probably proven and is commercial. It's been commercial for the last 2 years now.
Just to add something to that, if I may.
Please.
Yes, our process has no smoke. There's no burning. there are no fumes. The only byproduct that we produce is CO2. So while I agree with Mr. Smith on that particular process for burning, we do not do that process at the circular economy. There's no burning, there's no fumes, there's no smoke. Okay, the emissions of only CO2 are coming out from our process because it's a specialized proprietary process that produces the heat and the other processes that are utilized throughout that circular economy process. So while there may be some technologies that are doing that process, we do not have any smoke or any of that process taking place with our entire process.
Thank you so much, Adrian.
Can I add 2 cents? I know, I'm hoping that we're on overtime because we started late.
We're running a little close, and we have one more question we would like to direct to Ms. Madhu. But sure, feel free to chime in.
Okay, just quick. Sure. We need to address our landfills. They are producing methane right now. Methane is 23 times worse than carbon dioxide as a greenhouse gas. Yeah. So we need to be able to capture the methane. Even if we burn it, it is still better for the climate change situation than allowing it to be vented into the atmosphere. That's
yeah.
Thanks.
Agreed.
Thank you so very much, Mr. Baleo Singh. Timely and, as I say, informative response there. We have, well, there are many more, but we will take this opportunity to know that it's coming close to direct our final question to Ms. Madhu, and then it will be open up to the rest of the panel to give their thoughts as well. So it seems as though legislation is a reoccurring decimal in terms of the slowing of the process to get us from where we are in this present time in regards to carbon emissions. What do you think can be done at a societal level, to really help speed up the process?
Well, presently, that's one of the things that we are targeting right now in my project with energy transition in the Caribbean. And one of the challenges is that a lot of the energy policies, they have been drafted, but not approved. And apart from that, a lot of them don't have strategies or action plan in order to direct the government on where to go. But in terms of your society as a whole, they are looking forward for governmental approach and governmental legislations and regulations. And this is where CrossQ and the Secret has come in now to assist all our Caricom member states in putting together labeling schemes and codes in place so that we can help guide manufacturers, suppliers, and consumers in the direction in which to go. But we have realized as well that education is key, because a lot of persons are not aware of energy efficiency and climate change and moving forward in this direction. Because what happens is that if it is a government is allowing non-efficient technology, but you're preaching, let's be energy efficient, you're kind of contradicting yourself. So it starts with political approach. And there's also a bit of, contradiction between political persons as well. While the Minister of Energy would say, yes, let's be energy efficient, the Minister of Finance is going to be like, we can't. Like, how do we move forward with that? So for me, for a society, in order to target your consumption and carbon footprint, is to make energy efficiency your responsibility and not wait for the government to come in and tell you, hey, let me give you a light bulb to show you how it's done. Right? You have to know to target it before and not wait until that happens. But there are incentives in place, as our esteemed speakers would have mentioned as well. It's just that it needs to be more out there and inform people more about it, that, hey, we have these things in place, why don't you go get it? But it's not being advertised. Yeah.
Thank you so much for your thoughts on the matter. Well done indeed. Any member of the panel would like to add a few words before we give our final thanks?
Yes, I would like to add something. The problem is that we live in a very individualistic society. We don't live in a collective society. So the mindset of a lot of members is, I do what I want. Now, what needs to happen is you need to have a behavioral change. And how do you achieve that? Well, you can incorporate something called nudges into your plan. And therefore, by incorporating small changes, you achieve a larger behavioral change among the population. So if you not give them, and by saying this, it's not that I'm going to give away light bulbs so you can save money. No, you pressure people into making the change, but you have to pressure them in a way that is going to work. Because what we really are looking at is more of a behavioral change and a habit change than actually looking at energy efficiency, because of the type of society we live in. Thank you.
Just to add to that, as you rightly mentioned, of behavioral change, a lot of times you have persons leaving on their equipment at home and be like, that's fine. But if everyone thinks like that, then that negligible thing that you think is actually a significant impact on the economy and our consumption.
Yeah, and I'd like to also add to that the educational programs that we are now offering. Donald mentioned CZIT, which I'm also a part of. That whole educational programming that we need to set in place from our early childhood children moving forward into the future is what we really need. Part of our circular economy includes that entire educational concept that Donald is mentioning. And it is very, very important that we start off changing the next generation of children into where we are, more than forcibly saying to them, you need to do this or need to do that. Let them judge for themselves from the education that they're getting and spread that educational program into the adults and teenagers that are existing on the planet now. It basically boils down to leadership and foundational leadership that is so important, knowing where the foundation of the new roadmap should be. So moving forward, we need to look at education at the early levels, moving into the teenagers, then moving into the young adults, and then finally, hopefully the message gets to the full leaders that are in charge of political and other situations that change the paradigm from where we are to where the future should be.
Fantastic addition, Adrian. But as all things, at some point we have to come to an end. And I really hope that the listening audience was, much appreciative of the level of education and information that have been shared by our panel. As I always say, we need a greater commitment by governments and society as a whole to make more conscious attempts in the how we source energy, how we use it more efficiently. And I believe that how was truly demonstrated in the presentations today. That being said, before I pass on to Cherise to give the closing words and thanks, I would like the members of the panel to put on their cameras, please, so that we can have a picture taken. And Shanique, you'll indicate to me when you have already taken that picture.
Yes. Okay, we're set.
All right, and then can all the members who joined us today, when I mean members, the audience, all you lovely people that we are so thankful that took the time to be with us, can everyone, as much as possible, where it's possible, can you put on your cameras as well so we can take a group photo? Shanika, we good?
Yep, we're good.
Nice. That being said, I'd like to bring on Ms. Cherise Stowe. She would give our closing words and vote of thanks.
Hello, good morning, everyone. Good day, everyone. Thank you for being with us today. I am delighted as one of the Island Innovation Trinidad and Tobago ambassadors to deliver our vote of thanks and close off this fantastic discussion this morning. Firstly, on behalf of my fellow ambassadors, I extend our gratitude to our esteemed panelists, Mr. Adrian Dwen, Mr. Ignacio Smith, Mr. Donald Baldiosing, Mr. Curtis Udu, and Ms. Shalini Madhu. Thank you for your contribution and your presence here this morning. Thank you for your enlightening and informative discussion and presentations, and for assisting us in continuing the discussion of renewable energy, energy efficiency, sustainability in Trinidad and Tobago, and by extension, the Caribbean. Thank you. Thank you to the ASHRAE Caricom chapter for your partnership and your collaboration and support in hosting this event today. And I must also thank the organizing team, my fellow ambassadors, for your work, time, and enthusiasm in hosting this event. It was our intention to create a platform for education and to have an open discussion on the successes, challenges, and process of Trinidad and Tobago embracing energy efficiency, sustainability, and renewable energy in our community. Lastly, thank you to all our participants, our audience. Without you, this session would not be a success. Thank you for your active contribution, and we hope we were able to answer as many questions as possible. We look forward to seeing you next week, where we could continue this conversation on a worldwide scale at the Island Innovation Virtual Island Summit, which will be hosted on the 6th to the 12th of September. So please join us and let us continue this discussion further. We hope that you have a fantastic and great day, and for those in Trinidad, a fantastic and rainy day. And please join us, and we hope that you were well informed, and we just continue this discussion in embracing energy efficiency in Trinidad and Tobago. Thank you.
Thank you so very much.